Hello, good morning. Let me do this. And this. Shoink. Okay. Awesome, how's it going? Hello, Naifemi Bosun. Not sure how to say your name, but I'll go, let me go ping the Discord. There we go. Yeah, we'll give people a minute or two to trickle in. Then we'll jump in. Let's go ahead and open up the repo. Yes, okay. Hopefully somebody will be on that knows a little bit about this bootloader I'm going to be switching to. Hey Bacon, good morning. Hey Ivy. One more minute and we'll get started here. You guys ever seen one of these? It's pretty fun. Ivy has a melodica. Sounds like that. Keep it sitting on my desk just in case. You never know when you might need one. All right, let's jump in. We got, what, 10 people on? So should be good. Okay, so for those of you who were not present for the discussion on Discord, last two streams, thankfully you got a dedicated keyboard now. I didn't have to waste my breath now. Yeah, well, I have there's a keyboard right there too, like right by my neck, so I can reach it right here. Or I can't hear it, but I can reach the keyboard. But I also have the melodica, because sometimes I want sustained notes. Yeah, you guys can't really see my room, can you? All my instruments are in the other room. Yeah. Well, there's a keyboard right there. And then there's usually a bass and a banjo and a mandolin and a guitar and a dulcimer and another guitar and a saxophone back there. And some other things too, I forget what else. Okay, well yeah, so what was I saying? For those who weren't on the Discord, there's So I started by making um, my own bootloader, right? Following some of those baby steps on the OS Dev wiki, and then we kind of had to pull a small fortune in instruments. I mean, none of them are super high quality. The banjo is really nice actually, but none of the others are super nice. I mean, some of them are decent, but the banjo is the only really nice one. Um, and so we were talking about the bootloader. Oh, I lost my face here. Where'd I go? All right, we were talking about the bootloader. Sorry, what I was saying. And we kind of had a poll, and people decided that it would be better if, for now at least, I just pulled in an off-the-shelf bootloader and didn't try to roll my own. You're building both OS and programming language from scratch. Yes, except for what I just said is that I'm not going to be making the bootloader. For now, I'm going to pull in this one called Limine. Does anybody know how to pronounce it? Limine? Limine? I think it's Limine. I've been saying Limine. Limine? You personally voted for the BIOS. Yeah. Well, I mean, that would be cool. Why is this flickering? I'm flickering again. Okay, now we're not. I can always go back and write the bootloader later. So we're gonna pull in Limine. Unless anybody has a better way to pronounce it. So let me pull up a new, not that one, this one. What is it? It's like liminebootloader.org. Shoink. For the curious, there's that. Do you guys know if this is how you pronounce it? Alright, so Limine is a modern, advanced, portable, multi-protocol bootloader and boot manager that supports Linux, Multiboot 1 and 2, the native Limine boot protocol, and more. We know what a bootloader is, sort of. It's lightweight, elegant, fast, and the reference implementation of the Limine boot protocol. Okay. Limine boot. So Limine is a boot protocol, and this bootloader is like the implementation of it, I guess. So operating system and kernel developers that want to use a boot protocol which supports modern features in an elegant manner, like Grub's aging multi-boot protocols do not. So it's basically an alternative for Grub. Limine, says Bacon. Is it Limine or Limine? Bacon says Limine. Releases are available here. All right, how do we? Somebody sent me a didn't somebody send a bare bones? Here we go. Yeah, Cat sent this thing. This is Limine or Limine bare bones. So let's go through it and see. Limine. Oh, pronunciation is in the GitHub repo readme. Bacon says Limine. Or Limine? Limine? Wait, where's the repo? Hold on. Oh, here we go. Pronounced as demonstrated here. Wait. Where's there like a...
In Limine.
Whoa, that came out of my piano speakers. There we go. You guys can't hear that, can you?
In Limine. In Limine.
Limine?
In Limine.
Okay. So kind of limine. Limine? I feel like if it was Latin, it'd be limine. No? By the way, GNU Makefile provided in the bare bones didn't work for me on Apple Silicon out of the box. Okay. Well, we can tweak things a little bit. So is this kind of like where you're supposed to, what you're supposed to follow to set it up, or is there something else? Usage? Protocol? This is about the actual protocol. If you have problems with compiling the bare bones, you'll have to edit it and hardcode the compiler and linker. Okay, we can give that a shot. Well, maybe we'll just follow this then and see. This looks up to date. Okay, let's do this. Shoink. Okay, let me make this a little bigger. Maybe like that or something. All right, so basically our bootloader we don't really need anymore is kind of the idea. We have it in Git history, worst comes to worst, so we'll just get rid of that for now. README, keep that. Bootloader notes, okay, get rid of that too. Just file. We'll get rid of that. Well, yeah. To do. Get rid of that. All right, we're starting from scratch again. This is probably the fourth or fifth time I've done this for this operating system. All right, Limine boot protocol, or Limine boot protocol. Native boot protocol provided by the Limine bootloader. It is designed to overcome shortcomings of both boot protocols used by hobbyists. Okay. Yada yada, cutting edge features, 5-level paging support, 64-bit long mode support. This is what we want right here, 64-bit long mode. And direct higher half kernel loading. Limine boot protocol is firmware and architecture agnostic. It supports perfect, that's what we want right there. How to write a small Limine compliant kernel in GNU C. So I guess we'll write in C first and then maybe translate it later. Additionally, it is highly recommended to check out this repository, as it provides a complete buildable portable template code to go along with this guide. Oh, sweet. Oh, this is great. Again, can someone put up a counter at this point? Wait, a counter for what? I missed it. What happened? Oh, you mean when I was starting the project from scratch again? Yeah. Translate from C. Well, I just mean I ultimately don't want to write this operating system in C, so, but I'm fine starting it for now with C. So we have that repo open over here. Cool. Overview. For this example, we'll create these two files to create the basic directory tree of our project. So we're gonna have a source main.c, and then we're also gonna have a linker.ld. Day since Kai restarted the project 0. Exactly. As one may notice, there's no entry point assembly stub, as one is not necessary with a Limine protocol when using a language which can make use of the standard sysv x86 calling convention. Furthermore, we will download the header file, which defines structures and constants that we will use to interact with the bootloader from here and place it in the source directory. Okay. This thing. So you copy all this. Shoink. Is that kind of the idea? Stick that in limine.h. Is that what I was supposed to do? This thing is horrific. C++, oh no. There's few repos in GitHub on the GitHub organization which provide working templates for other languages. If I understood correctly, you don't want to write the kernel in C. Correct. I want to write it in my own language. Lovely. You can write it in C and use that to write it in Lovely later. Yeah, let's just start with C. C is probably good. Unless we want to do Rust. Is there like a simple Rust template? Look at that. Limine Rust template. Oh, it's forked from the C template, but it's Rust. I mean, we could just copy this. Ooh, I might do this. But there's not like a... Well, let's just do the C one, I guess, since there's a... Bacon says not Rust. Okay, we'll do the seed one. So okay, there's no, we did that. We downloaded that. We got that here. Place in the search directory. Okay, we got that. Obviously, this is just a bare bones example, and one should always refer to the Limine protocol specification for more details and information. This is the kernel main. All right, now we got to write our main. I'm gonna write this out instead of copying and pasting because it helps me understand better. So we include what do we do? Standard int. Get a few of these. So we also have standard def, standard bool, and limine. Why can't I use this? Can some C nerd out there? Did I just join on the making of a main file? Yeah, it's a good time to be here. If anybody's ever able to tell me that, I'd love it. Hello. I'll copy over the comments. So, joink. So the base revision to 3, this is recommended as it's the latest base revision described by the Limine boot protocol specification. Okay, and then we will, what is this attribute thing? To do limine h with brackets, you have to add -isrc, capital I, to your C flags. What does that even mean though? Why? Attribute used section limine requests. Static volatile. What does volatile mean? Base revision 3. Why is this being formatted like this? Is this normal? Mako. I don't use perplexity. I never use perplexity. Do you guys all use perplexity? Perplexity. I can barely even say that. Perplexity. Angle brackets tell the compiler that it should search in pre-specified paths. Gotcha. C flag just adds your search directory to the list of directories to search. Okay, that makes sense. Thank you. It's not very happy about this. Like I kind of wanted this to be here and this to be here, but it's not buying that. You thought I do use it? Yeah, no, I've never really used it. One, I don't understand what this is supposed to do. Two, I don't understand what it is doing, which is kind of why I wanted to use Rust, because I would actually understand what it's doing. I don't know, guys. I'm kind of tempted to do the Rust one. All right, I'm gonna do the Rust one. Sorry, guys. Apologize. Can you not read C? I mean, basic stuff I feel like is sort of fine. Like I have no idea what this is. What's this attribute thing? Oh, do these get mapped? Yeah, let's just go with Rust one, just so I understand it better. Dependencies. All right, so we just need to do all this, right? So we need to, so kernel ends up being, okay. So now we have kernel here. All right, then just a few things to pull in here. So let's go to dependencies. So they're pulling in this guy. So I guess there's a Rust crate for this thing, which is nice. And then there's this, which is main. And you say, okay, no standard library and no main, yeah. Okay, and then use core arch asm. This is how you do inline assembly. See, I've never done the inline assembly. That's interesting. I'm about to see how it's done. Okay. Attributes for variables, functions, types. Okay, that's interesting. Use core arch asm. Use limit. So we have limine base revision, and also limine request. Close this out. Frame buffer request, request end marker, and request start marker. This guy. There we go. Okay, and then that's fine. If we do like that. Oh, this doesn't like that. Doesn't like unused imports. That's all right. We'll fix them. So this will set the base revision for the latest revision supported by the crate. See specification for further info. Be sure to mark all limine requests with used, otherwise they may be removed by the compiler. Gotcha. So we mark this as used, and then we say unsafe. And then okay. And then same thing here, right? And then that's probably supposed to be start, right? This becomes used, unsafe, link section equals request start marker. Static start, oops. Marker is a request start marker. We can do one of those and then kind of do the same thing. Oops. For end, which becomes an end marker. Oh, so you're saying that whole underscore underscore attribute, this thing is like equivalent to one of these? Is that what you're saying? That's interesting. All right, and then we need to, oh yes, so unsafe, no mangle, so it doesn't rename it. And then unsafe, extern C, function K main, so kernel main, turns never. Assert that base revision is supported. Update the link section for the end marker. Oh, thank you. Thank you. I got it, Ivy. Okay, we say some frame buffer response. And we reach out to our frame buffer request dot get response. Because this returns, what does this return? An option of a response, right? Okay, so if we have one, then we say, okay, if let some frame buffer response frame buffers dot next. Right, we do it in here. Gotcha, thanks, Bacon. Okay, in Swift, you can like chain these things together, and it's really nice. But it's all right. All right, so then we say for I in 0 to, what is this saying? U64? Oh, it's gonna do something. Oh, that's cool. We copy the comments, shoink. Let pixel offset equal I times frame buffer dot pitch. What's the pitch? Okay. Plus I times 4. And then we write 0x ff. This is unsafe, folks. Unsafe. Frame buffer dot adder. What's adder? The address of the frame buffer. Okay. Add. Cast to U32. Why is this so mad at me? Oh. We need to make HCF now. What does HCF stand for? We'll get the panic handler in a second. This just loops forever. Figure. Perfect. x86 64 asm HLT and then we'll configure any target arch 64 target arch risk v. Well, we're only doing the one, right? But I'll just put these in just in case. All right, and then we do asm with e, and then target arch long. Why are there two O's? 64. Whoa. Somehow the LSP knows my... This is super interesting. Knows my architecture. It knows that I'm on ARC64. And so these ones are grayed out. That's crazy. That's nuts. All right, we need a panic handler, right? So since we disabled the standard, okay, handler Rust panic. Core panic info. Yeah, I got these before. I think it's fine. Maybe. We'll try. We'll see what happens. Okay, we're getting places. We're getting places. And now what do we do? So this guy, so that's our, that. Car tell me we already got. Okay, there's build.rs. That's interesting. Oops. That goes up in here. And we say let arch equals standard and var cargo config target arch dot unwrap, and then we tell cargo to pass the linker script to the linker. We say print line, oops, cargo rusty link arg equals dash t linker arch dot ld. And to rerun if it changes. What are you working on now? I'm working on incorporating Limine, the bootloader, into my thing. All right, I'm gonna go study. I'll see y'all later. I'll try not to restart it again, Ivy. Print line cargo rerun if changed equals linker arch.ld. Okay. And then there's all these linker files. Which one do I need? Because I'm on RH64, but I'm trying to build this kind of operating system. Which one do I do? We just get both of them for now. Shoink. Gonna add linker x86 64. And then I'm gonna add linker arch64. All right, there's those. And then, oh, that's toolchain. Ooh, you do have to do that, don't you? And we're doing x86 64 unknown none. All right, and then there's this giant, well, there's this, some sort of configuration. Okay. And then there's this GNU make file. This thing's a beast. I haven't written a make file in a long time. GNU makefile. Terrific. Well, we can try this. I think I got everything. Oh, there's another GNU makefile in here. Good grief. And that should be everything. Yeah. All right, now go back here. Make all will compile the kernel, generate a bootable ISO image. Make all HDD will compile the kernel and then generate a raw image suitable to be flashed on USB. Okay. Make run will build the kernel on a bootable ISO and then run it using QEMU. Let's try that. Do I need GNU make? No rule to make target run. We've got a phony run. What happens if I just go in here and cargo run? Fail to install component. Okay, so to make target run. Um, run. I'm stumped, guys. I'm stumped. What does dot phony do? I have no idea. I do not understand makefiles. I'm definitely not planning on using one long term if I can help it. You have you have to have indentations. For example, after run, you have to have a new line and a tab. Are you saying this has to be like that? Oops. Is that what you're saying? No, after the semicolon. What semicolon? Here? These are the only semicolons. Oh, you mean the colon? Oh, it's my sister's birthday. I need to text her. After here or after here? The top or the bottom one? Because they don't have that in here. This is what I copied it from, and they don't have those indentations you're talking about. Baffling. So alternatively, instead of copying this giant configuration, we could try to like build it ourselves from scratch. See this example? If you're gonna send a link, it's not, YouTube's not gonna let you. You can't send links in chat. I mean, here's the crate. Doesn't really give you much. I feel like that might be better. All right. You can use Discord. Oh, for the link. Yeah, yeah. Yeah, I'm a little bit let's try okay, we'll reference this and we'll reference this. Okay, so this is that and this is that. Okay. So I'm gonna try this again. Somebody tell Ivy we're starting from scratch again. All right. I'm going to cargo new kernel. I'm gonna make a kernel. All right, we have a target. We add a get ignore here. All right, go in here. We're going to down here. Limine. Okay, so now we have Limine. Does that make it 5? Something like that. Restart for no reason. I mean, the reason is that it wasn't working and I had no idea what any line of code was doing in that make file. And so I went to, let me see if it's possible just to kind of like build this up myself. So so we know we want no standard library and no main, right? Because we don't have access to those things. No standard and no main. All right, so now we don't have a main and there's no standard library. All right, so first thing you need to do is place a base revision tag somewhere in your code. This tag is used to identify what revision of the protocol your executable requires. Without this tag, the bootloader will assume revision 0, which is likely not what you want. The base revision tag can be placed anywhere in your code, like so. So you use limine base revision. And then you say, not bub, pub static base revision base revision new. So with the latest revision. So now we have the latest revision. Next, you can place any requests you would like. For example, request to a larger stack recommended on debug Rust builds. I probably don't need that. Like, what happens now if I try to build this? Joink. Nope. Oh yeah, we need to make a panic handler. So that's pretty easy, right? Don't you just go like panic handler, and then make like function Rust panic. What does it get past? It gets past never, right? All right, returns never, and it just loops forever, maybe. I feel like I've seen this done. Oh, it takes panic info. Isn't there one here? Oh, it takes a reference to this. There we go. Excuse me. So that's mad, but I think it's wrong. Nope, it's not. Unwinding panics are not supported without standard. If you use nightly cargo, then you can use this with panic equals abort to avoid unwinding. Oh, panic equals abort. I remember seeing something about this before. How do you do that? Panic equals abort. Shoink, shoink, shoink. Here we go. Yes. Well, we'll do it on here. And we should also do the same thing for debug. So now it won't try to unwind. Aha. This is supposed to be dev. Okay, now we're getting linker errors. We're onto something here. Yeah, there's also that like bootloader crate. But I guess this is only 32-bit. Anyway, all right, so now we have linker errors. So that might be something that this guy figured out how to fix. Where would you be resolving these linker errors? Linker. One of these linker files. Rust toolchain targets. Let's do that. Okay, so Rust is toolchain.com. We say toolchain and we say channel equals nightly maybe, and then target. I'm not sure if we'll need this. Target equals $64 unknown none. Same linker error, right? That didn't really fix anything. Now it's downloading lightly versions. Yeah, it's the same error we had before. Okay, so we're not gonna use nightly for now. Stick to this. Linker, command failed. Okay, so maybe we need one of these like linker guys over here. I don't know, maybe. So what are we doing? We're doing x8664, right? So let's do this. Joink. This goes right here. We say linker x80. You think I'd be able to type this by now? x8664.ld. That we want this sort of output. Entry k main. Oh, we don't have a. We don't have a k main. Oh, this means we need to make that like external. Okay, so this is telling if entry should be that k main. We don't have that k main. K main, right? So they made this k main, which is like an external using like this C protocol thing. So maybe let's make one of those. I don't know. So we need to make sure it's not mangled. And then we want to unsafe extern C function k main. We'll call it kernel main. I think that's better. It never returns. And it really just loops forever. Allow that. That's fine. Okay. So now we have that. So now if I go over to our linker script, we should say the entry is kernel main. Not sure what those are. PT load. What's PT load? Oh, we didn't make these. So note. All right. Okay. Maybe it's not using this linker thing. Is that what this build did? Yes. Tell Carter to pass the linker script to the linker. Okay, so we do need that. So let's add build.rs, which just means a main. Which it's really just all this, right? Joink. Well, except we already know our architecture, right? This is x8664. Unknown options dash T. That's different, isn't it? That'd be like this thing, right? Arg equals dash T. I don't know. Unknown options dash T. What did that just do? It's Kotlin multi-platform. Yeah, no, it's not it. Instead of a cross-linker? Any thoughts, chat? This has this dash T here. So that's what I have. Um, hmm. What does that guy Phil Opperman do? There's... This looks really helpful. Actually, wait, let's try what this guy has. I mostly have what he has, I think. So wait, get rid of, because he does his own linker thing. Okay. So he says, distilling the standard library. Say no standard, and then you make some main. You make panic handler. I guess I can just call this panic. And that's basically exactly what I did. Okay. And then you disable unwinding, which is what I had too. So you go in here. Oh, you do it for dev and release. And now if I say, okay, we go to this. I'm getting a linker error. It's not what he's getting. Oh, but he has a main. Right? Yeah. Okay. This function main requires a standard library. Okay. Tell the rest compiler we don't want to use normal entry point chain. We add the no main. Okay, so we do this. We get rid of main. And then we need this thing, right? Oops. C star. So this guy's calling it start. It's fine. We don't mangle it so we don't get name mangling. Because if you name mangle, you get something like this, right? And we don't want that. We use a C calling convention, which is what this means, extern C. If we run cargo build now, we get an ugly linker error, which is exactly what he says you should get, an ugly linker error. John's code, this is amazing, thank you. Linker errors. Okay, the linker is a program that combines the generated code into executable. Since the executable format differs between Linux, Windows, and Mac OS, each system has blah, 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 blah. Okay, the fundamental cause of the errors is the same. The default configuration of the linker assumes that our program depends on the C runtime, which it does not. To solve the errors, we need to tell the linker that it should not include the C runtime. We can do this either by passing a certain set of arguments to the linker or by building a bare metal target. We want to build for a bare metal target, right? Rust tries to build an executable that is able to run in your current system environment. For example, if you run Windows on x86-64, which Rust tries to build an exe Windows executable that uses those instructions. This environment is called your host system. To describe different environments, Rust uses target triples. Yep. Okay. So you're saying I can do this? This is just an example thing, right? Oops. No? Okay, so it does that in the next section, I think. Okay, so the boot, yada yada. Okay. We're targeting this system with our kernel. It'll look a lot like that. Start by creating, okay. x86 64. This is humble os.json. This describes our architecture. So no idea what this data layout means, but this is right. Like it's okay. It's that. Yeah, little endian, 64-bit. C and width 32. I guess that makes sense. OS none. Maybe executable is true. Not sure. Most of this makes sense. A few of them don't. I don't get that. I don't get this. And that kind of makes sense. Okay. Now that we changed the OS and the LLVM target and the OS fields to none. Oh. Gotcha, because we want to run on bare metal. Sure. Add the following build related. Oh wait, there's more. There's more. Add linker flavor LDA LLD and add linker Rust LLD. Instead of using the platform's default linker, which might not support Linux targets, we use the cross-platform LLD linker that is shipped with Rust for linking our kernel. Oh. Panic strategy is abort. This is like what we did in the cargo.toml, right? This thing specifies that the target doesn't support stack unwinding on panic, so instead the program should abort directly. This has the same effect as the panic abort option in our cargo.toml, so we can remove it from there. Okay, so I can get rid of this. Disable red zone. Writing a kernel, so we need to handle interrupts at some point. To do that safely, we have to disable a certain stack pointer optimization called the red zone, because it would cause stack corruption otherwise. For more information, see our separate post about. Okay, we'll just trust this guy. Disable red zone. There's that. Then we do all these features. Features field enables disables target features. We disable the MMX and SSC features by prefixing them with a minus and enable the soft float feature. Okay. These features determine support for SIMD instructions, which often speeds the program significantly. However, using large SIMD registers on OS kernels lead to performance problems. The reason is that the kernel needs to restore all registers to original state before continuing uninterrupted program. This means that the kernel has to save the complete SIMD state to main memory. So we disable SIMD for our kernel, not for applications running on top. Okay, that's good, because we want SIMD later on, right? The problem with disabling SIMD is that floating point operations on x86-64 require SIMD registers by default. To solve this problem, we add the soft float feature, which emulates all floating point operations through software functions based on normal integers. Okay. For more information, see our post on disabling SIMD. And then we do this. So the whole target specification should now look like this. I'll just make sure I have the right one by copy pasta that. Yep, nothing changed. Building our kernel. Compiling for our new target, we'll use Linux conventions since the LD linker flavor instructs LLVM to compile with the flavor GNU flag. This means that we need an entry point named start as described in the previous post. We already have that, right? This guy. Okay. Now I can say cargo build dash dash target x80 that. Can't find crate for core, which is what this says too. Fails. The error tells us that the Rust compiler no longer finds the core library. This library contains basic Rust types such as result, option, and iterators, and is implicitly linked to the all no standard crates. The problem is that the core library is distributed together with the Rust compiler as a pre-compiled library, so it is only valid for supported host triples, okay, but not our custom target. If we want to compile code for other targets, we need to recompile core for those targets first. That's where the build stud feature of cargo comes in. It allows to recompile core and other standard library crates on demand instead of using the pre-compiled versions shipped with the Rust installation. This feature is very new still and still not finished, so it is marked as unstable and only available on nightly Rust compilers. Oh dear. To use this feature, we need to create a local cargo config at, okay, so we got a cargo config.toml. We're going to say unstable build stud core compiler, core compiler built-ins. Okay. This tells cargo that we should recompile the core and compile the built-ins libraries. The latter is required because it is dependency of core. In order to recompile these libraries, cargo needs access to the Rust source code, which we can install it with a rust-up component add rust source. Note, the unstable.build stud configuration key requires at least the Rust nightly from that date. After setting the unstable, okay, hold on. After setting the unstable and running that, we can build our build command. It's because I'm not using nightly. How do I tell it to use nightly? Excuse me. Nightly. Installing Rust nightly. Oh, here we go. I skipped this whole section. You rust up. Rust up, use rust up install nightly. So now I have a how do I like rust up use nightly? How do I decide which one to use? Additionally, alternatively, you can add a file called Rust toolchain. That's what I thought. Okay, Rust toolchain, which just says nightly. Comipler? What's a comipler? Comipler, compiler. Troink. Okay, it's looking good. It's compiling. It's building core. It's compiling. Oh, it worked. Surprising. Okay, so that built. So now we have something in here. Something in there. Okay, and then so we did that. Did that, we did that, and then it builds. Yeah, okay. Okay, memory-related intrinsics into it are build features. The Rust compiler assumes that a certain set of built-in functions are available for all systems. Most of these functions are provided by the compiler built-in crate that we just recompiled. However, there are some memory-related functions that in the crate that are not enabled by default because they are normally provided by the C library on the system. These functions include memset, which sets all bytes in memory blocks to a given value, memcopy, which copies one memory, okay, whatever, and memcomp, which compares two memory blocks. We didn't need any of the functions to compile our kernel right now. While we don't need any of them to compile our kernel right now, they'll be required as soon as we add some more code to it, like when copying structs around. Okay. Since we can't link to the C library of the operating system, we need an alternative way to provide these functions to the compiler. One possible approach for this would be to implement our own functions. However, this is dangerous since the slightest mistake in the implementation of these functions could lead to undefined behavior. For example, implementing memcopy with a for loop may result in an infinite recursion because for loops implicitly call that trait method, which may call memcopy again. It's also a good idea to reuse existing well-tested implementations instead. Fortunately, the compiler built in the crate already contains implementations for all the needed functions. They're just disabled by default to not collide with the implementations from the C library. We can enable them by setting cargo's build stud features flag to compiler built-in mem. Well, how nice. So we say what? Build stud features compiler built-ins mem. Okay. You need Rust Nightly. Okay. Behind the scenes, this flag enables this feature. Yeah. So the default target. Oh, that's good. Config.toml. You can say build target equals x86 64 blog. No, what's mine? Humble os.json. Okay. Coolio. Now I shouldn't have to pass the target along. I can just do cargo build and it just works. Cool. Print into screen. Okay, so then it runs off into VGA stuff, and then it starts working on a bootloader. It just pulls in this bootloader crate. We could just use this bootloader crate. Except that, But that's like specifically a rush crate, right? And ultimately this is going to be lovely, so we should probably stick with Limine. Although Limine doesn't exist in lovely either. So we'd have to make like our own Limine implementation in lovely or something. Wait, you restarted the project as in you deleted everything and started again? I think I've done that 5 or 6 times now. Yes. But I've never gotten very far, so it hasn't been a big deal. All right, so now we should try to incorporate Limine, I'm thinking. All right, so back to here. Do we still have that as okay, Limine, and then all right, first thing you need to do is place a base revision. Iterations do improve skill. Yeah, each iteration has been, we know something's gone wrong. So I've learned something each time, but Place the base revision tag somewhere in your code. This tag is used to identify. Okay, the base revision tag can be placed anywhere in your code, like so. Okay, let's try this. Use Limine base revision. Let's pop one of these in here. Pub static. How can I make this not error? Pub static base revision equals base revision new. Coolio. Why is Rust Analyzer quitting on me? What? Check log. Unknown binary Rust Analyzer and official tool chain. Oh. Did I fix it? Hey, I fixed it. No way. Would you look at that? What do you mean you can't find crate for test? That's ridiculous. Not sure what's going on there. Hey, Robin. Welcome to the stream. Wait, whoops. Are we still building? Yeah, we're building. I'm getting this weird Rust Analyzer is kind of confused. Can't find crate for test? I have no idea why it's saying that. Alright, we'll just ignore it for now. So we got this base revision thingy going. Cool. Next, you can place any requests you would like. What are requests? Maybe I should read about this Limine protocol. Anybody in chat that's used Limine before? Limine. There's that protocol. I just put them all under Esteban. That's funny. Um, Not sure if you know about this. Maybe you can take some inspiration from this toy OS. XV6, a simple Unix-like teaching operating system. What is it? XV6? This guy? Made by MIT, yeah. Fascinating. That's really interesting. Is there not? There's not a single directory. Everything's flat. That's interesting. Very nice. Yeah, I'll check that out. In the meantime, gotcha. There's not much documentation on this whole Limine thing. Like, there's that one template. That's like all I got. I guess we can just look at what this guy's doing. So, um, so he did this. He does this like use link section thing. Like, what does that even do? Use link section. This is unsafe. Still builds. Says the base revision to the latest revision is supported by the crate. See specification for the info. Be sure to mark all Limine requests with use, otherwise they may be removed by the compiler. Oh, gotcha. And then you do another one down here. Wait. Whoops. What's happening? Whoops. Okay. What I meant to do is to copy this. I'm gonna do that. There's that. And then that still is building. So now how do I get like something I can boot now? That's the question. Um okay, yeah, like what is this guy running our kernel? Adding the bootloader as a dependency is not enough to actually create the bootable disk image. The problem is that we need to link our kernel with the bootloader after compilation. But Cargo has no support for post-build scripts. How do we link our kernel with our bootloader? I guess we could look at this guy's make file. Like, which one would it be? This one or this one? Run art. So if you do run this, what's OVMF? Crikey. Okay. Whoa. That did something, actually. Boot failed. So, I mean, that's not great. How to get bootable image from Rust binary. Typically use a tool like boot image. Like this guy, you mean? To create a bootable OS image from a kernel binary. To do cargo install boot image. Oh, so it's just a binary. I already have it. So I have boot. Now, how do you ever use boot image? I think it talked about it in this thing. Let's go here in cargo. You add a dependency on a crate named bootloader. See, what is boot? But is bootloader gonna like override my Limine thing? Bootloader. I mean, I could just use this thing. I'll just have to like rewrite it myself when I switch to Lovely. Hmm. Yeah, so this is like an alternative. This doesn't use any, like the Limine protocol. It's like an alternative. Uses UEFI or BIOS. Um, I don't know, chat. What do you think? Um, just gonna use C.
Otherwise, then we're having a terminal, and which points to the terminal which we can access, and we can do this.
Yeah,
And we are actually writing.
that was C. Um, well, I don't know. Maybe I'll just try to get it set up with bootloader here. Man, this stuff is so complicated. Okay. So we have a kernel binary. It just needs to be ran somehow. It's exactly what this do, but this requires that I use the bootloader thing. Right? You need this. If you want to use a custom bootloader with a different name, you can use Cargo's rename functionality. Wait, what are you talking about? When writing a dependency section in Cargo, package. Oh. Why don't you make a bootloader from scratch? That'll be much fun. I already started trying to do that. And we talked a bunch about it in Discord and decided not to for now, but I very well might come back and do that. Okay, wait, so you're telling me I can do something like bootloader version that's kind of nuts. Okay. So then oops. Oh, I gotta change the name. Okay, so this is still Limine. I just aliased it to bootloader to make this boot image happy. If you want to use custom bootloader with a different name, that's what I'm doing. Use cargo's rename functionality. What if I pass it a target? Package metadata bootloader. What if we tried that? What is it? Package metadata bootloader target. Maybe we should just trod the happy path and use the bootloader crate. Whoa, what did I just do? Whoosh. I don't know, chat. I don't know. Any suggestions out there? Recommendations? Oh, there's people messaging me in Discord. Guys, I've not been looking at the at Discord. um. I would not recommend using the the Rust bootloader, since you will switch to another language. Yeah, that's why I'm so hesitant to do it. Um, What if I try cloning this down? Like getting everything exactly the same. This guy. Use this template. I've never done this before. Use this template. Let's try it. Limine test. Um, oops. So now, I literally have the exact same thing. Wait, that actually did something. Do you see that? Why is it working now, but it wasn't working before? Good griefers. Failed to install components. It's conflicts. Failed to install component, Rust standard. And then what is this? Where would that be? Okay, I feel like we're kind of close right now. Does anybody in chat know what's happening? It says failed to install a component Rust standard for unknown none. Type of conflict. Like, where is this coming from? Is there some sort of like find command? Clearly this find isn't working because it can't even find my learning thing. What is find? Walk a file hierarchy. Oh, yeah, that's different. Shoink. This isn't even this. Look, I'm pretty stumped. Pretty stumped. Ivy's back. How are we doing? Do we pass any milestones? I think we restarted from scratch 2 more times since he left. And nothing's really working. Kind of stumped currently. I cannot figure this out. Any idea, Ivy, where this error is coming from? $9.40. I probably need to be done here soon. Let me do Google searches. I've tried. Here we're going to be reinstalling that tool chain. What's the error? Rust up toolchain list dash v. This is what I got. Don't know what you're looking at, but hold on. Okay. Hello, Lord Pyjo. Are you late? We've been going for 2 hours and 10 minutes, so just a little bit. It's all right though. Sorry, I need to respond to something. Okay. Oh, Cat. Boy, do we need you, Cat. Have you used Limine? You're too focused making a TUI? Oh, cool. What's your TUI? I'm curious. Cat, we need help. Help us, Cat. You never used Limine. Oh, never mind. Oosh. Only used grub. Well, there's a sad lack of documentation for Limine, which appears to be a common theme with OS development, I've noticed. Did you follow the Limine tutorial in OS Dev? This guy? No, because I wanted to do it with Rust. We're trying to do it. There's this like Limine crate. See? System linear equation calculator. Oh, cool. I wanted to use this. Wait, no, this is the C one. Where's the crate? This guy. There we go. But and there's like this bare bones. Cat is switching to his PC. He's gonna help us out. Thanks, Cat. Okay, here's a slightly unhinged solution. Why don't you just try like RFing the conflicted file? Well, the conflicting file isn't even something that like exists. It's doing lib, but where is this? You know what I'm saying? Like, what do you mean lib? Where is lib? What? That does exist. But the toolchain, like which toolchain? Your default toolchain? Is this one. But I'm using nightly to build this thing, aren't I? I'm using nightly, so it'd be the nightly one, right? We're onto something here. Manifest Rust, blah, 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 no, none. This one? Manifest Rust stud x8664 unknown none? Or wait, or is it this whole thing? No, it's this one. Some person, I'm curious, why are you sending stuff over in the Discord instead of the YouTube chat? It makes sense for links and stuff, but generally speaking, I check the YouTube a little more often, but I appreciate the help. This guy, Shoink. Okay, there's that. Now if I, what is it? That's a different error. That's almost as good as no error. Wow, okay. Ivy, your unhinged solution was killer. Lord Pyjo says it'll work for now, but not for later. What? Remove target? Cargo clean is a thing? What do you know? Yeah, legal option -M. Like, where is that coming from? And it's also saying is a directory not copied, which would mean we need like the dash R flag or something, right? It's the make file, yeah, but what? Run. So run goes to this guy. Dash M. Wait, is that it? No, no, no. Little option. Oh, it's for find. It's not on that one, it's in this one. Here we go. Is this the one? Where do you get every single piece of code here is from the the Limine Rust template. Here, I'll set it in chat. Oh man, I feel like we're like close to getting there. I wonder. Isn't that usually how this works? You'd like do dash dash for the long words and just dash for short things? See how it's saying illegal option M? As if it's only parsing dash M and not the whole max depth. I wonder. See, now it says legal option dash. Okay, so it's only parsing whatever comes right after this dash, right? Because if I do dash dash, maybe like find works different on Linux than on Mac OS, and that's the problem or something? Looks super complicated? Yeah, it is super complicated. But it's literally the only example I found. Find a legal option dash dash M. I wonder if that's a common issue. Am I using gmake? No, I'm using make, but I have gmake. But it's saying the same thing. Wait, what did I just do? Whoops. See this? If I just do this right here in my terminal, it says that's an illegal option. This is the same exact error. I think we're onto something here. A illegal option error when using find on Mac OS. First argument to find is the path where to start looking. Oh. You'd have to install find utils? Wait, kernel. Okay, so I just need to move kernel to over here. Right? Shoink. Oops. Kernel, no such file or directory. What are you talking about? There is one right here. No? What are you talking about? Do I need a trailing slash? Maybe. says no such file or directory. You can pass it a file or a directory, right? But what is this find even trying to do here? What am I looking for? Find utils? What is find utils? All right, brew install find utils. But that doesn't move find. Like, what do I have now? How do I then? Oh. Check it out. gfind. So we use gfind here. Something happened, all right. It can't find our chorizo. Can't find chorizo. Isn't that like a, this is what I picture when I think of chorizo? So I need to install the chorizo. What is chorizo? Is it on Homebrew? Chorizo macOS. Sure enough, brew install chorizo. What is chorizo? Copies files from POSIX compiled file systems into Rockridge Enhanced ISO 960 file systems and allows session-wise manipulation of such file systems. Oh, now it all makes sense. Just kidding. It doesn't. Now make run. Guys, it's working. Hey, Jose was here this whole time. It's a line. That's what that thing did anyway. What? It was supposed to be a line, wasn't it? I mean, this is probably supposed to be drawing a line, I'm assuming. Let's go, guys. This is pretty epic. Now, frankly, I hate makefiles, and I'd love it if I could just do this all with a just file. But the makefile is super complicated, yeah. I feel like I want to try to simplify this a lot and switch to just. Any objections to that? Might not do it today, but... Ooh, Rasawe has the important parts in your repo. What's your repo? I can't believe that worked. This is so cool. I've never seen such a nice GUI. So I'm going to, okay, first of all, this is in like this temporary like learning Limine test thing, or Limine. I need to copy this all over into my real. Okay, this shouldn't be a big deal. So if I go, okay, wait, stop doing that. Copy this all over into Humble. Oh wait, I can't copy across things. How am I gonna do this? Okay, so basically, in Discord. Where in Discord? Endcraft. I missed a ton of stuff these past weeks. What are we doing right now? Hey, welcome back, Endcraft. The language is still going. Lovely is still in development, working on that a bunch. And then right now, I just finally got something sort of working. Like this. I was making my own bootloader. Whoa. Do you see that? That was really cool. It actually showed the Limine bootloader. Now this is our operating system right now. It's a line. So I was making my own bootloader, and then we decided that was going to take forever and it could be really hard. So for now, at least, I'm just using Limine, which is like an off-the-shelf bootloader. That was actually kind of a pain to set up, but it's nice now that it's working. So I need to copy this over. And then what else did you guys say? Did this take 2 hours? Yes, this did take 2 hours. 2.5 hours. All right, I need to do some wizardry here. Okay, so I need to get rid of all of this pretty much. I get rid of that. I can keep the readme, get rid of the get ignore. Okay, I'm going to just move stuff out of here until it's ready. So move that, humble. Now I have the kernel, perfect, okay. And then that gets generated automatically, right? Okay, get ignore. Get ignore. We'll do the GNU makefile. We'll do the limine.conf. What does that leave us with? That was automatically generated. All right, let's try it over here now. So if this is back in Humble. Just switch to Humble. So if I go up here and can't believe my unhinged solution worked. I was half expecting things to break. Yeah, well, I mean, it made sense. Make run. Oops. Please work, please work, please work. It's booting, it's booting, it's booting. Enter for boot. Okay, shoink. Perfect. So this still works. So I'm going to, uh-oh, I lost my cursor. Control, Alt, G. There we go. All right. Hello world. Well, it's not really hello world. I guess, booting with Limine or Limine. Push that to master. Shoink. So it generates this thing, which is just get ignored. It generates this thing. I have no idea what these are for. Limine, I guess, but they're get ignored. And then generates this ISO, which is cool. Very nice. So next step, I feel like for me will be simplifying a lot of this. Like how much of this do I actually need? I feel like these GNU make files are kind of overkill. This is 250 lines of making it general across like every architecture, which I definitely don't need. I feel like I could break that and this down into one simple just file. And then we're going to start working on the operating system. Yeah, Cat agrees that it's way too overkill. Well, I think it might make sense maybe for the template because like it's trying to show people how to do it for every architecture, you know? But all right, really glad I got that set up. All right, what do you guys think? Good stopping point? I should probably be done. I have to teach some classes in a minute, so. Kat, you were helpful. Also, just a warning, gfind in macOS is macOS find utils exclusive, I think, to make it cross-platform. You probably have to make an alias or something. Yeah, that makes sense. I'm not too worried about like cross-platform yet, so. All right, things are looking good. I'm going to stop there. Is it going to be full GUI? Totally. Yeah. Very GUI-ish. I mean, we'll probably start with just like a terminal-like interface and then go to a GUI. But unless we decide to start with a GUI. That's what I think Andreas Kling did with Serenity. I think he was like, well, what's the most interesting to me? He was like, I really want to work on the desktop environment. So he started working on the GUI first, and then he went and did other stuff. So will you start the OS in Rust, or is the Lovely ready enough? Lovely is not close to ready enough. I'm probably going to end up doing something like, yeah, I'm going to start this in Rust. Wait, by the way, did I push to? Yeah, I did. Okay. I'm probably going to start this in Rust and then, but go kind of slow because I'm going to be focusing more of my efforts probably on Lovely because that's what I really need to get done to really start on this. And then translate what I have into Lovely at some point, which will be also good for like dog feeding. Lovely. So something like that. We'll kind of just see what happens. I don't mind starting it in Rust. Cool. Well, yeah, thanks everybody for being on. And next stream, what day is it today? Thursday? Yeah, next stream should be tomorrow. Actually, I might do I'll probably do a Lovely stream this afternoon. And then I'll do probably 2 more tomorrow as well. So yeah, I'll let you guys know in the Discord. Thanks for the help, everybody. Until next time.